Okay, so in this video, I'm going to go through how to find the equations of tangents. This is something that pupils in my group have been struggling with a bit, so I want to make sure there's a video out there which just goes through the standard method on how you would do this. And I've created a simple example, or a simpler example than the ones I've seen in books on this type of problem. So here's an example where we have a circle and we've also got the tangent drawn. Sometimes you'll get the diagram, sometimes you won't. So it could be written up something like this where they will give you the basic kind of information that goes along with it. And the idea is that you would want to find the equation of that line. Now to start off with, there's not enough information for you to just go straight in there and find a gradient for this line directly. You have to put a bit more work into it beforehand. The only two things we can tell about this line is that its intercept is somewhere between 8 and 9 on the y-axis. We can see that the line goes through there. So assuming this diagram is drawn to some sort of scale or suitability, we can tell that. And the only other thing we can tell is that the gradient would be negative in a traditional y equals mx plus c type graph. So they're the only two things we do know, but I'm now going to go through the method that you would use in order to solve this. So in the solution, the start point would be to work out the equation of this line, which goes through the origin and through the point that we've been given. Now, if we look at this line, because on this line, or this line contains the radius for the circle, what it means from circle theorems is that the angle between my orange line and the line that I want the equation for is 90 degrees. The tangent and the radius do form an angle of 90 degrees, and we're going to use that fact in a bit. So first of all, the equation of this line. Now, the gradient for this line is fairly straightforward to work out. If the point was somewhere else on the circle, you may have a negative gradient to start with, but you are going to use this information, and so we can get that the equation of this line will be y equals 3/4 x, where the gradient is 3/4, and the intercept is 0 because it goes through the origin. And so the next stage really is, well, how do you get the equation of the perpendicular line to this, the one that we want, now that we know this information about this orange line? And this is where, if you have done this previously, some knowledge about how to find gradients of perpendicular lines is useful. So looking into this, the gradient of a perpendicular line is the negative reciprocal for the gradient of the other line. So we already know that this orange line has a gradient of 3/4. So the gradient of the line we want is the negative reciprocal of 3/4. So starting off, that purple line now, so I've just color coded it a bit, is going to have a gradient which starts off being the reciprocal of 3/4, which is 4/3. Standard method here is just to swap numerator and denominator around. And because it's a negative reciprocal, we're going to change the sign of it. So if our previous gradient had been negative, then we would end up with a positive gradient now. But as it was, we've gone from positive to negative, and we've also gone from 3/4 to 4/3. I'm not going to change this improper fraction into a mixed number just yet, and I might not do so at all. It depends how I want to leave my answer at the end. But at the minute, all I now need to figure out is the intercept. So in the question, what we did get given was a coordinate that was on the line. So to get c, we'd substitute those values of x and y from that coordinate into the equation that we've currently got. So substituting them in and then tidying up a bit, we'll eventually get to the point where we'll figure that c is 8 1/3. And I have rushed through those steps, but if you just check them and use inverse operations, you should see that it works out. Now 8 1/3 seems sensible for an intercept. When we see the line, we can see that it is between 8 and 9, probably closer to 8 than it is 9, so that seems like a reasonable answer to have. And I'm now going to put that back into the original equation at the start to then finally. Now then, having substituted the intercept back into the original equation, I could leave it in the format that it's in. But most of the time I have seen it rewritten so that the fractions are not present, and you also rearrange it a bit so that you generally have your x and y terms on the left and a number on the right. So if you want to do that final part, then the first thing you do is change any mixed numbers into an improper fraction, which is why I didn't change the gradient in the first place, so that I could do this later on. But now, since they both have a denominator of 3, to get rid of that, I'd multiply through both sides by 3, which would give me this equation, and then I'd neaten it up a bit by moving the 4x to the left by inverse operations, giving me 3y plus 4x equals 25. Now, having gone through this example, which is a fairly simple one, and the reason I chose the circle I did was because I could get a nice whole number coordinate, everything was going to work out reasonably well. Questions in exams will be trickier, but the method and the process is still the same, and that is what you want to try and stick to when you answer this type of problem. If you're not so sure that you can get all the way through the question, just do as much as you can, and then by demonstrating that, you should pick up some marks through your method. Hopefully this video has proven useful. If you'd like to leave any comments or anything below, then please do so. Thank you.